Welcome to this video on effect sizes in the classroom. This video is designed to help you understand what effect sizes mean and how you can calculate them so you get a better idea of the impact of your teaching on students' learning. One of the most important questions that we as teachers can ask is, how do we know if our teaching intervention has been effective? Effect sizes are one way of helping us understand how effective our teaching interventions have been. So it's a really useful tool for teachers. It's not the only tool, but it is a great tool to help us explore student data and understand whether what we've done with students has been helpful, and then reflect on what we could change about our teaching practice to have better impact on student learning. There are some terms that I will use throughout this video, and I want to make sure that you understand what I mean when I use these terms. So we're trying to develop a common understanding here so that what I say throughout this video will actually be helpful. So the first terms I want to discuss are pre-test and post-test. So a pre-test is a test that I would deliver before a unit of teaching and learning, and a post-test is a test that I would deliver after the unit of teaching and learning. Now, what's really important when we're calculating effect size is that the pre and post-test match one another. They should have the same number of items or questions, if you want to call them that, on the test, so that the highest possible score and the lowest possible score on each test is the same. Not only that, but the items should be matched in terms of difficulty. So the easiest question on the pre-test is as easy as the easiest question on the post-test. Same with the hardest question and every other question. Each question should have a corresponding question on either test. That way, the tests are the exact same difficulty and it is fair to compare them. What counts as matched on an English test is obviously going to be quite different than on a match test. So this might be a professional conversation with colleagues to determine how we can change the questions if we need to, so that they're testing the same skill at the same difficulty without being the exact same question. Another important term that I'm going to use is standard deviation. Now, a standard deviation is the average difference that each student's score is from the average score. So this is a really useful measure of how close the majority of students are to the average. So sometimes we can have an average and the top scores and the bottom scores are all a long way from what ends up being the middle score. But sometimes we can have an average and the scores, the individual scores of students, are actually all really close to that average. So the size of the standard deviation gives us an idea of just how far most scores are from the average. The lower the standard deviation, the closer they are to the middle score or the average score, and the higher the standard deviation, the more variance there is in the data, the further scores are away from the average score. Lastly, I'm going to be talking about effect size, which is the whole point of this video. Effect size is basically the impact that the teaching intervention has had on student learning. And of course, we'll go into that in much more detail throughout the video. All right, so now let's actually look at how we calculate effect size. We start by calculating the averages for both the pre-test and the post-test. To calculate the average, we're just going to select the cell at the bottom of the column we're calculating our average in, And so I'm in the pre-test column here, and we start the formula with the equal sign. That's just so Excel knows we're doing a formula. Then we type in the word average, we open up the brackets, and then we enter the array of cells that we'd like the average calculated on. So the first value is in C2, then I hit the colon, and then I hit the last cell, C14, in my array, and close the brackets, hit enter, and the average will be done for me. The next thing I do is I just select that cell again, and I select that little green square in the bottom right hand corner, drag it across, and it's now doing the average formula, so I don't have to type that in again, but it's doing it for the post-test column. So you can see it's changed the formula there to be D2 and D14. It just makes it a little bit easier to do this quickly. Now that we've calculated the averages, we need to calculate the standard deviations, again, both for the pre-test and the post-test. Calculating my standard deviation is really similar to the average. I type in equals, but instead of average, I'm going to type in STDEV dot S. The difference between the S and the P that you just saw is whether or not all of my students did the pre-test and the post-test and received the teaching intervention. Most of the time we'll have absences, so we need to use standard deviation .s. Okay, if you're absolutely sure that all your students received the teaching intervention and you've got both pre and post data for all of those students, then you can use the .p, but normally I would encourage you to use .s because that will be accurate if you don't have all that data and the students didn't receive the intervention. So once you've typed in standard deviation .s, then you open up the brackets, and again this is going to be the array C2 colon C14, and we'll close the brackets and it will calculate the standard deviation. Once more, I'm going to drag my little green square across, so I've got the standard deviations of both my pre-test and my post-test. Our last step in calculating effect size is to get the effect size itself. We're going to use the averages and the standard deviations to help us do this, and this is the most complex step in the procedure. Please feel free to pause the video as you go, especially if you're calculating your own effect size, so that you make sure that what you're putting into Excel is the same as the formula I'm using. Excel doesn't know how to calculate effect sizes, so I'm going to have to put this formula in manually. So please follow these steps really carefully and pause if you need to. So I'll start with equals, and then I'm going to open up my brackets, and here I need the difference between my post and pre-test. So I'm going to put in cell D15, and I'll use the minus symbol, and then I will subtract C15 from that. I'm going to close the brackets and put in a /, which tells Excel to divide, and I need to divide by my standard deviation, or the average, sorry, of my standard deviation. So I'll open up the brackets, I'll put in the word average, I'm going to open up the brackets yet again, and here I need both the cells that contain my averages. So I'm going to start with C16, then put in a colon, and put in D16. I'm going to close my brackets so that it knows that that's the numbers it needs to calculate there, but because I've opened the brackets twice, I'm going to put in the brackets again to properly complete the formula. Then I hit enter, and this is my effect size. Once we have our effect size, it's time to interpret it. We have a few different types of data to help us make an interpretation. We have the averages, the standard deviations, and the effect size itself. So the first thing we might want to look at is the averages. We'll compare the pre-test average to the post-test average, and obviously we're hoping that the post-test average is higher or better than the pretest average. Next, we can have a little look at the standard deviations. Again, we're going to compare the pretest to the post-test score, and if the average has gone up, then we want the standard deviation to either stay the same or maybe have shrunk a bit. So what this means is that the whole group has gone up. So the average has got higher and the whole group is a little bit closer to that higher score than they were to the lower average of the pretest score. Don't panic though if your standard deviation has got a little bit bigger. That's fairly normal because some of your group will learn really well from the teaching intervention and some of your group just may not for various reasons. And that's okay. What we can do is look at the effect size to give us a really good picture of just how effective our learning sequence has been. So what we're hoping for is an effect size of 0.4 or higher. When we get an effect size of 0.4 or higher, we are achieving something that is greater than the normal effect of teaching interventions. And this is possible. It's possible to get a score well above 0.4 quite regularly in your teaching if you're using high leverage teaching strategies. If you get a score between 0.15 and 0.4, that's fairly normal. This is what teaching strategies, teaching interventions usually yield. Okay, so don't panic too much if it's down there, but you should probably be disappointed if your effect size is between 0 or maybe even less than 0, all the way up to 0.15. What's happened there is just the students have learned developmentally, or there might be another reason that they've done better on the test, but it's probably not the teaching intervention. And if they've gone backwards, then obviously something's gone really wrong, and that's a time where we'd need to do some really solid reflection on our teaching practice. So to summarize, what we really want to see is an effect size of 0.4 or above. And if we do get that, we need to have a look at our teaching strategies that we've used and figure out which ones were successful, which ones helped us get this really good effect size. If we get something lower than that, then we might want to start researching what are some high leverage teaching strategies that I didn't use and how can I use them next time I help students try to understand this skill. You may not want to listen to this part of the video, and you certainly don't have to. It's just a little bit of bonus content. Sometimes it can be useful to calculate an effect size for each individual student. And then you can see which students are responding to your teaching intervention really well and have grown heaps, and which students maybe haven't grown as much. And over time, if you keep collecting this data, you might notice some patterns which will be helpful for you as a teacher to reflect on your teaching practice, as well as students' attitudes towards learning and other variables that might be affecting teaching and learning in your classroom, to help you better meet the needs of students who are both doing well, but the ones also who are doing poorly. I should warn you though, an effect size for each individual student is far less accurate than the effect size for students as a whole cohort. When we get the effect size for students as a whole cohort, some of the anomalies in student data sort of cancel each other out. Some students do a bit better than they normally would, some students do a bit worse than they normally would, and it kind of balances out across the whole group. You don't have those effects when you calculate the effect size on an individual student. So it's not a very reliable indicator, but it can be helpful to see which students have powered forward and which ones are lagging behind. Now, this is a bit more complex than calculating effect size. We're going to have to use the $ in Microsoft Excel. The $ is a useful tool And what it does is it tells Excel not to change the cell that you're referring to in the formula when you copy the formula into other cells. All right, so we want it to continue to look at particular cells in our formula. We don't want it automatically changing, which Excel very usefully is programmed to do, but sometimes we don't want it to do that. So I'm going to show you the spots I need you to use the $ and make sure you pause it at each one if you need, so that you are getting your $ in the right spot as well. This is just a matter of repeating my effect size formula, but I'm going to start up next to my first student's post-test score. I'll type in equals again, then I need their post-test score minus their pre-test score. So I'll get that by doing D2 minus C2. I'll close the brackets and then I'll hit divided by, and again, I want the average standard deviation. So I'm going to type in the word average, open up the brackets again, but this time I need to start using the $, and this will tell it not to jump around cells when I copy the formula in a minute. So $C, $16. So every time I put in a letter or a number that I don't want to change, I'm going to use that $. So I'll hit in the colon again, $D, $16, close the brackets again, and hit enter. Now it's simply a matter of copying the formula down to my other cells, and there you go. I have the effect size for each individual student in my cohort. There you have it. That is how to calculate an effect size. Plus, we've looked at some of the key terms like standard deviation as well as pre and post test. What you can do now is you can rewatch this video and pause it as you go while you do your own Excel spreadsheet so that you can calculate effect size yourself, and just skip back and forward in the video if you find that you've made an error so that you can see what it is you might have done wrong and hopefully fix that problem. Happy effect sizing.